lovely viewers and subscribers. Welcome to JT Electrical Engineering STEM. Today is a special day and we are going to treat on a topic called parallel and series connection. And today we have two subtopics to look on. And today we'll be solving an intensive calculation on both subtopics. So let's take our notes. So here we have series circuit. So under series circuit, what do you have? Series circuit. In a series circuit, the current that flows through each component is the same and the voltage across the circuit varies. I'll take it again. In series circuit, the current that flows through each component is the same and the voltage across the circuit varies. So let's come down to our parallel circuit. Under the parallel circuit, we have our note. We have in parallel circuit, the voltage across each component is the same and the total current is the sum of current flowing through each component varies. I'll take it again. In parallel circuit, the voltage across each component is the same and the total current is the sum of current flowing through each component varies. So let's go back to our calculation. So today we are going to take a question under series circuit. So question 1, it says a current of 20 amps and 3 resistors of 6 ohms, 4 ohms and 2 ohms are connected in series. Calculate the total voltage in the circuit. I'll take it again. A current of 20 amps and 3 resistors of 6 ohms, 4 ohms and 2 ohms are connected in series. Calculate the total voltage in the circuit. So we are going to calculate the total voltage in the circuit. So let's go calculate. So back to the question. So if you watch my previous video on how to calculate resistors in series, we learned that if a resistor or resistors are connected in series, we sum them up together to find the total resistance of resistors. So if you haven't understood just what I said now, you can go to my previous video and watch how to calculate resistors in series. Now it implies here we have our resistor 1, resistor 2 here and resistor 3. So we have to find the total voltage. Before we do that, we have to sum the resistors together. So my calculation here, so I have my solution here, which I'm going to find the total voltage in this circuit or component. So I have here I'm going to sum the resistors up. So resistor 1 is equal to 6 ohms, and then resistor 2 is equal to 4 ohms, and then resistor 3 is equal to 2 ohms. So now here I'm going to sum them up. So we have here RT means total resistance. So RT the formula is RT, total resistance, is equal to R1 plus R2 plus R3. We have here R3. So now we are going to sum them up. RT is equal to R1 is 6 plus, to bracket, sorry, plus 4, and then plus, and then 2, giving us with ohms. So 6 plus 4 is 10, plus 2 is 12. So our RT is equal to 12 ohms. So now we have our 12 ohms now as the resistor, calculating for the resistor. So we are going to move forward to calculate the total total voltage in the circuit. So let's come down here. So our total voltage, so I'll make an illustration of the component. So our RT here is 12 ohms, which is our total resistor. Then our current is 20 amps. So leaving us with the voltage, we are going to find the voltage. So we are going to use a formula called Ohm's law. Then if you can remember, we learned about Ohm's law, all the formulas we learned about it on my previous video. So if you haven't get it yet, go to my previous video, how to solve for or calculate for resistors in series. So we are going to use the formula called Ohm's law. So here we have Ohm's law state that so we are going to use a formula called Ohm's law. So V, voltage, is equal to I times R. Voltage is equal to current times resistor. Voltage is equal to current times resistor. So we have our V is equal to I. We have R here. We have the current is 20 ohms. So 20 times the resistor here, we have our total resistor is equal to 12. So 12. So our V is equal to 20 times 12. So we have our 20 times 12 is 240 volt, which is our total voltage. So I would explain it again. So our component, which is the resistors, are connected in series. So we have our 6 ohms, and then the 4 ohms, and then the 2 ohms, and our current is 20 amps, and then the voltage, we are asked to find the voltage. So we have to make this one, we have to sum this one up, the resistors, the components, we have to sum them up to get a fixed resistor, which means we have to sum all of them up to get a fixed resistor. So here we come down to R1 is equal to 6 ohms, and then 4 ohms, and then 2 ohms, which is the R1, R2, R3. So we come here, so we use the formula. So RT, total resistor, is equal to R1 resistor 1 plus resistor 2 plus resistor 3. So here we have our formula here. So down here we have RT. We continue to use this formula. So RT is equal to bracket to open 6. So 6, R1 is 6 plus R2 is 4 plus R3 is 2. So we sum all of them up and we had our 12 ohms as our total resistor. So now we can find the total voltage in the component or the circuit. So now we come back to make our rough sketch, which is our total voltage is 12. Sorry, our total resistor is 12 ohms and our current is 20 amps. So we continue to find the total voltage. So we use a formula known as Ohm's law. So Ohm's law. So if you haven't had any knowledge about those formulas, there are many. So if you haven't had any explanation or understanding about those formulas, go to my previous video on how to calculate for resistors in series. There you find those formulas and you know them down. So here we have Ohm's law. So voltage is equal to I, current, times resistor. So V is equal to 20. 20 is the current here. We are basing it on the formula. So 20 is the current here. So 20 times the resistor we had so 12. So leaving us with our answer. So total voltage is equal to 240 volts. Thank you very much. We'll continue to solve another question on parallel circuit.